Divergence would have been inconclusive. The limit is 0. Because the degree on the bottom is higher than the degree on the top. So the limit would be 0. Yeah. But I appreciate that's a good idea in general. Is why waste time doing anything if the test for divergence says it's divergent, right? But everybody's limit was 0. Sorry. Okay. Even yours. Okay. Yep. Anything else from the quiz or from homework? Let me go back and let me see if I can give, what was it again?
Number 55.
No, 36, yes?
Oh.
So you were sort of close with, dear God, don't make a piecewise function, but come back to me. Let me give you, here we go. Let me give you an example like what you need for number 36. This is section 11.2, by the way. This is a question somebody had about this problem. Let me basically tell you the answer to that by telling you the answer to a different problem. So if I had this series, yes? So this one is similar to the problem from the book, but the tops are all 1, but still, every other one has got a different idea to it, yes? This is a little more in your face. They're definitely very distinct. Do you guys see what I mean? If I took out the second, the fourth, the blah, 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 what am I left with? If I took these, I'm left with 1/2 plus 1/4 plus 1/8. Those are not squares. What kind of sequence is that?
2n.
So what kind of series is that? What's 1/2 times what is 1/4? 1/2. 1/4 times what is 1/8? So I keep multiplying by the same thing. So that is a what series? Geometric. What's R?
1/2.
1/2. Is everybody with me? Now, I took out an infinite number of terms, didn't I? So next to here, I'm going to put all the terms I took out. 1/5 plus 1/25 plus 1/125, ... Isn't that its own geometric series? So whatever the sum of this one is, and whatever the sum of this one is, I'm going to add them together. And that'll give me the sum for the whole thing. So you will see series where it seems like there's 2 series embedded together. You can tease them apart. Thank the gods you don't need to write them as a piecewise function, right? And if I can sum every other term and sum every other term, I sum those sums, I'm done. So here R is 1/2. What's the first term? 1/2. Here R is 1/5. What's the first term? 1/5. Does anyone remember the sum?
A over 1 minus R.
So this will be 1/2 over 1 minus 1/2, which is 1. You with me? And this would be, let's try to be a 1/2 there. Don't look at this screen, Jeff. This would be 1/5 over 1 minus 1/5, which is 1/5 over 4/5, which is 1/4. So then what's the sum of the original? 1 1/4 or 5/4, up to you. Yes? Kind of makes sense. If I have an infinite number of numbers and I add up all the the second, the fourth, and I add up all the odds, and then I add up what I get from both of those, that's all of them. Do you see that? So that's not going to happen like every other problem, but it will happen every now and again. Okay. There was another problem earlier like that was like, what is the limit? It was like 1/3, 1/2, 1/5, 1/4, every kind of, but you can see each kind of distinct sequence was going to 0. So there's several ways I would accept an answer. You could say if I look at these, I get 0. If I look at these, I get 0. So the whole sequence is going to 0. I don't know if you guys remember that problem. Okay. Anything else from homework or from the quiz? Yes?
For 11.3 number 6.
Wait, no, is that different? Yeah, I think it's, okay. And it don't matter what section, 36 is hard. Oh yeah, this is good. Oh no, this is the one. Oh, sorry. So this is the one I told you. If somebody will remind me, or if I somehow magically remember, I have the proof of this. And I do kind of want to talk about the proof because it's so flippin' cool. And when I say that, I have no idea how that makes you feel. But so they're telling you that this weird looking dude is equal to pi squared over 6, yes? So I know that. This dude took time and he figured it out. He did a really cool little thing. Like Euler was like, come on, Euler, leave some shit for other people to do. It's like, no, I will not. God damn it. So I had to poison him. So word poisonings in the history of math. So if I wanted to figure out this, what is the difference between this question and the thing that I know?
N equals 1 versus N equals 2.
Here's a way to say that. This is missing this guy's first term. So should, you guys see that? This guy starts at the first term, he starts at the second term. So should this sum be bigger or smaller than this? Smaller, he's missing a term. Exactly what is he missing? What's the first term?
1.
1. So what's he sum up to be? Pi squared over 6 minus 1. That's the thought process you use. Does that make sense? You guys see that? If I start at 1 and another thing starts at 2 and they have the same function inside, one is going to sum up to a little less, right? If they're all positive terms, you with me? Okay. Does that make sense by itself? That idea is going to become kind of big later in chapter 11. What's up?
No, I'm fine with that one. I'm just curious as to how in the world
Yeah, look at this
B
one.
and C work.
All right, look. We did something like this earlier. Didn't I rewrite, well, there's my 14th puberty. Didn't I rewrite the form of a geometric so it didn't have an n minus 1? Remember that? Okay, this is the other thing that's going to become huge later this semester. What have I done with all my paper? There it is. So watch this. Oh crap, let me zoom out a bit. So real quick, when I plug a 1 in, what do I get up top?
2.
2. And when I plug a 1 in, what do I get on the bottom?
4.
1.
Or, yeah, 1. Sorry.
So what if I wanted to, for some reason, I wanted to make it start at 0?
0.
So I want the series I'm about to write to have the same elements this one did. I want these to be equal to each other, yes? And I need you to understand why I can do this shit. It's the same reason if I don't make n equal 0, if I make n equal 1, my geometric has an n minus 1. If I make it start at 0, it has an n. So I can kind of shift the variables inside. So if I make what I'm working with go down by 1, I have to make what is working with it go up by 1. So if I put n plus 2 over n plus 1 squared, when I put a 1, I got a 1. When I put a 0, what do I get on the bottom now? 1. When I put a 1, I got a 2 on top. When I put a 0, what do I get on top now? 2. They're the same series. Just one of them starts at 0, one of them starts at 1. Why will that be important? We'll find out. We're gonna try to combine two series. And what's the only kind of thing you can add? What's got to be true about two expressions you're trying to add? This is really, really, really basic. They have to be not fractions, but it's an application of fractions, right? Like the denominators is an application of like terms. Yes? So if I want to add two series, I have to do something related to like terms. So that's going to become important. You guys see how that's just shifting? You guys remember like translating functions? That's basically what that is. And how do you check to make sure you did everything right? plug it in, make sure you get the same numbers you did before. Yeah? But does it make sense? That first series, does it make sense when I say what it's working with? It's working with 1, 2, 3, yes? If I shift what it's working with down by 1, I have to shift what it does with it up by 1, yes? That's the idea. And then I still get the same outputs, yes? Okay, bye-bye. Bye-bye. But that's really going to come into play later this semester. But this is our first little, taste of it. Okay. All right. So that question should be a little funky, but it's trying to get you to play around with this before we introduce it formally. Anything else from homework? Yes.
It's on the online homework. It's 11.3. Do you want to look at it, or do you want me to say it?
It'll tell me which problem it is if you look up
Six.
here. No, I mean, it should tell me. Oh shoot, I guess it doesn't tell me. Oh, here it is. 31. Oh. Haha. Is it this?
Yeah.
Okay. Some of them they change and some of them live alone. Live alone? Some of them live alone.
I think mine, it just has 3 on top, but it's the
Oh,
same
okay, okay.
otherwise.
So this one wants you to find the value of P for which the series is convergent. Now, if you follow, the book did the same thing we did last time. It proves the P series idea. Do you guys, what's P series mean? What form would a P series be in? 1 over n to the P. And what's it required for it to converge? P must be greater than 1. How do you remember that? The bigger the bottom, the more likely it is to converge. So if I raise the n to a bigger power, it will more likely converge. So P greater than 1 makes the bottom bigger, makes the whole thing smaller. Yes? Because I will point out what kind of sucks is that what does it take for a geometric series to converge? R has to be less than 1. But that's because I'm multiplying that shit by itself. It better not be a number bigger than 1 or else it's just going to grow crazy, yes? You just have to remember why those two separately make sense. Okay. On this problem, it is not a P-series. Do you guys agree with me? That is so not a P-series. It's not in the form of a P-series. It's not n to a power, yes? So what you have to do is you have to apply the integral test to this the same way that we did with 1 over n to the p. That sounds very exciting, but just to point it out, I think the book did it, didn't they? We did this together, but I'm pretty sure they, wait, here it is. No, you assholes, where is it? Well, we did it together last time. I thought for sure they did it. Wait a minute. No, okay. But we proved the P series last time. So what we did was we integrated 1 over n to the P. We said, what if P is greater than 1? What if P is less than 1? Which one of those actually leads to a convergent integral? Yes? So that's what you have to do for this one. What's the nice thing about having to integrate this problem here? What method do you see is going to work? You can do it. If I integrate 1 over x natural log of x to the p, what method is going to work to integrate it? U sub, yeah, natural log of x is 1 over x derivative, right? U sub will work directly. Then you just got to say, if p is greater than... Now you got to think about what's the dividing line. So you have to set up the interval and follow it to see if you can see what makes it converge. Okay. Give it a try. Anything else? I don't know if it helped there, but that's all I can tell you. Apply the interval test. That's what you need to do. Yeah.
You said something about showing a better way to do.
Oh yeah. Real quick. Just to show you a different way to do something like 4 points. No. Point 273, 273, 273 forever, yes? Okay, very quick. Every decimal that stops or has a repeating pattern can be written as a fraction. You with me? You with me? So everything that cannot be written as a fraction doesn't stop and has no pattern. For example, the square root of 2. 1.414, blah, 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 blah. It just keeps going forever. There's no pattern to it. Doesn't stop the damn thing. You guys, if a decimal stops, isn't it automatically a fraction? 1.38 is 138 over 100 because it's in the 100th place. Yes, 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 yes. The number of decimals is the number of zeros you put underneath. And if it has a pattern, here's what I could do. Do you guys know what this is as a fraction? No, so I'm going to call it x because I don't know what the shit it is, right? You guys with me? What sucks about this number? What very obviously sucks about this number? It just doesn't frickin'
It doesn't
stop. It has a freaking infinite thing, yes? How much would I have to multiply it by so that the infinite part kind of like realigns? If I multiply by 10, want to be 2.732732, it doesn't align? Do you guys see what I mean? What do I have to multiply it by so I make the repeating part align again? 1,000. What happens when I multiply by 1,000? It becomes 273 point, right? 1, 2, 3. 273, 273, 273, 273. Very Christmassy. Yeah, I'm sorry. I don't know if anybody's ever seen this before. All right, what I've done so far, the part that sucks is the infinite part. Yes? So if I could just cancel that shit, I would feel so much better. Yes? So now, can't I subtract those? Can't I subtract? What's 1,000x minus x? If you say 1,000, I think I'm gonna go crazy. 999x. What's 273 minus 0?
273.
And what's 0.273 minus 0.273? 0. So then what's x?
273.
And what did I say x was? X was the fractional part. So if you do 273 divided by 999 in your calculator, it will tell you 0.273. And this eventually is going to give up because it's only got so big of a screen, yes? You guys with me? You can reduce that. Do you see that? But who cares, right? So, all right. Okay. So one of my favorite ones, real quick, is if I do 0.111, I just have to multiply by 10. Do you see that? To make the infinite part line up, yes? And then that's 9x equals 1. X is 1/9. Why does that make sense? Well, what's 3/9? Isn't that 1/3? And what's 1/3 is a decimal? 333. And what's 3 times this? 0.333. That's 3/9. So 1/9 is 0.111. So 2/9 is 2/9 is 0.2222, and 3/9 is 0.3333. Something you guys already knew. We just finally caught up. Okay, I'm sorry. Just to show you an alternate method than what the book shows with series. When you do the homework, you do the series, but you can do this on the side if you want to. Okay. Okay. Does everyone have? Do I have it? What have I done with it? Am I writing on it? No. Does everyone have the handout from last time? Oh, here it is.
Which one?
This one. The one from last time. Does anyone need this? Let me say it that way. Anybody else? You guys good? Okay. Don't be embarrassed, if you ever forget to bring it. I've got an extra, so it won't make too much fun here. So, I didn't have geometric series on the quiz today because I thought I'd want to give you more time to kind of like sit with them. You have to memorize the formulas too, yes? Right, what's S? A over 1 minus R, I like it. Yes, and you have to know the form of it, blah, blah, blah. Okay. Oh, did we do these? Yeah, what did
Yeah.
we not do? We did these.
We did everything
Oh, yeah, we
but
stopped here.
11.4.
Sweet, perfect. So remember I told you last time this is actually 11.5?
Okay.
I just shoved it here because there's room here. So let's,
Then where's 11.4?
it's back here,
Oh.
poor little guy. So we're actually gonna talk about this first, why not? So we've seen examples of alternating series already. The -1 to the n kind of dependence, yes? So every other term has got a different sign. Alternating series are officially ones where every other term is the opposite sign. Do you agree though, like cosine n has some positive, some negative, but it doesn't change every other term. It does a few and then it changes to negative and then a few later it changes to positive. You guys kind of with me? It's over and then it's under and then it's over, but it's a few. Okay. This test will only work if it's truly alternating. So look at number 2. Why does number 2 make sense? Why does number 2, the requirement, number 2, for this kind of series to converge? Why does that make sense? What's number 2 really? What's the first thing you do if I give you a series and it's not an immediate geometric or p-series? What do you check? The test for divergence. What's the test for divergence? If the limit
if
of an
Is
not
not zero.
zero,
Then it's divergent.
it diverges, and we talked a lot about that. It only makes sense. If the limit is not 0, it eventually is adding some number forever. And of course, that I don't care what that number is, it's going to go to infinity. The limit must be 0 for it to have a chance to converge. Notice what this says. This says actually a lot. This actually says every element of this has to be positive. Do you see that? These are both greater than 0, yes? What is an plus 1 versus an? What is an plus 1?
The next.
The next term, good. So the next term, wherever I am in the series, the next term must be smaller than the term that came before it. You guys with me? So, number 2 seems to say that, but couldn't I have something that goes up and then it goes up not quite as far and then it goes up not quite as far? Are you with me?
Mhm.
So if my series is doing that, it's not officially alternating, it's not going to meet those requirements, I can't say it converges. So I need, for my series, to not be increasing and the limit must be 0. Number 2 is kind of silly. The limit's got to be 0 for it to have a chance anyway, yes? Why? So compared to integral tests especially, or geometric or whatever, do you all agree that sounds a lot easier than those?
Yeah.
Didn't you just see, why does that make sense? Isn't every other term in the sequence an opposite sign? So shouldn't it be less difficult for this to converge? In fact, here's one of the coolest visuals. All right. We'll be the judge of cool jar. So let's say I'm going to make it Bn just to be different. And it's got the -1 dependence, yes? You guys all with me? And it meets the requirements. Okay. So what is the first element of this? So it's just,
One.
yeah, it's, well, let me make it like this. I wanted to, it doesn't really matter, but let me just do this. Okay, what's the first element? You can do it.
1.
B, 1. Okay, there you go, okay. You with me?
Yeah.
Now, real quick, I'm going to start to collect my sum. I'm going to kind of collect it in a row here. What would I add? What would the next term be that I would add on to get my S2?
negative
Minus?
B2
B2. What would the next term be that I
plus B3.
plus B3? You with me? So, real quick, watch. This is kind of cool. Do you all agree that no matter what, B1 is finite? Right? Because if I had like 1 over n minus 1 and it starts at 1, I'm not going to even look at that series. It's like that has no chance to begin with. So we're going to assume that all the B elements are finite themselves. Does that make sense? What you with me? So I start at some number and then I take away from it and then I add to that and so forth. Yeah. So here's a beautiful visual. So I'm going to start at B1. Yes, whatever B1 is. And then I subtract B2, but if I subtract TB2, can I possibly go under 0?
Yes. No?
How does B2 relate to B1?
It has
It's
to
at
be
most equal to it, yes?
smaller.
So I could maybe go to 0, but let's say that when I subtract B2, I get here. So this is my S2. I'm going to start putting like S's now, because I'm going to do my sums. You guys with me? So S2 is this. What am I going to do from here?
Go forward.
Add B3, and at most, B3 could get me back up to here, yes?
Yeah.
So I'll say it's somewhere in between. Let's go a little further. So this will be S3. Does everybody understand what's happening? Every time, first element, then I'm going to take away from that at most as much as that was. Then I'm going to add to that as most as that was, and I'm going to subtract. So every time I move up and down, it's like a pendulum slowing down. No idea if you guys are with me. God damn it. So, then I'm going to subtract. I'm going to go to S4. Then I'm going to add. I'm going to go to S5. Does that have a chance to go to infinity?
No.
Hell no. So if I'm meeting this condition, and my elements do go to 0. If the elements did not go to 0, couldn't I start doing this thing? Wee. Yes, if my elements did not go to 0, couldn't they just add 1, subtract 1, add 1, subtract 1? Is that convergent? No, that's a type of oscillation, yes? So maybe a specific example. What about this? What's the first term? 1. What's the next term? Negative 1/2. So I'm going to take 1/2 away. Is that cool? So this is S2, yes? So I took a half away. Is that cool? And now what am I going to add to that? What's the next term? 1/3. So I'm going to add 1/3 to that. So I'm going to go 1/2 plus 1/3 is 5/6. Yes, good. And then I'm going to subtract. Do you guys see this happening concretely? So as long as each next element is less than or equal to the one that came before it. Now, obviously, so it could repeat sometimes. But the fact that the limit is 0 means it can't stay the same value forever. But it is allowed to sometimes be the same number. So if I just plotted my function, it should look like this maybe, and have a little shelf, and then it goes down the little shelf. Yes, so sometimes it could stay the same number if it wanted to. Poor little dude. Okay, maybe that visual's not as great as I thought. It's a good little visual. Okay. So if you see a -1 to the n or -1 to the n plus 1 in your series, you just have to check 2 things. Is this true? And is the limit 0? Yeah, and is the limit 0 is like one of the first things I would do anyway. So let's look at these examples. There we go. Is the limit 0? Yes, you can just see it's 0, yes? And again, that's taking this out of the way. Taking this out of the way. It's 1 over 2 to the n, 2n minus 1. That's definitely got a limit of 0, correct? And I want to point something out about that last problem we just did. If I took the -1 part out, what does this series do? We know what this series does. What's it do? It's a p-series. P equals 1. So what does it do? Diverges, yes? But if I put the -1 in there, it makes sense that it didn't I tell you 1/n is on a knife edge?
Mhm.
If I make the power 1.0000001, it converges. So if I instead make every other element negative, it should be really obvious. Well, shit, yeah, that's going to converge now. Yes? Hell yeah. The whole problem was it was adding to itself, so if I just make it take away from itself sometimes, it's like, I can't get to infinity. Oh, shit. Yeah? Okay. Maybe. So, we get a problem like this. We see the -1 dependence, yes? And I just do by two things. I do the limit. So I'm working with the Bn, that's the part that's not got the -1. I see that, I set it aside, and I work with the part that's next to it, right? The 1/2n-1, yes? That limit is obviously 0. That's satisfied, check. Now, can somebody tell me, how do I check this other requirement?
Is it,
Could somebody
Squeeze
tell me?
theory?
could s-
Theorem?
No, think on. Can somebody tell me what an plus 1 is? Well, let's maybe start with what's an. What's an? What's an? 1/2n-1, yes? So what's an plus 1? That's if I stick an n in, huh? Not quite. Replace n with n plus 1, yes?
and then -1.
So I get an is 1/2n-1, and I get an plus 1 is 1/2n plus 1, yes? Can you guys see, could you explain to me that these two are, that is definitely smaller than this one? What could you say? Why is that one smaller than that? Because that's what we need, correct? I need the second dude to be less than the dude that came before, correct? Or at most equal to it, yes? Why is this smaller than this?
Because
Because the denominator's bigger. I'm dividing by more. So you could actually just say that. You could say, Jeff, dude, that's bigger because the bottom's bigger. Leave me alone. Both requirements met. Converges. Next. Yes? Can you always see it this easy, though? You know the answer to that's no. Okay. I've used up all my room. I love it. I gave no room for this anyway. So let's look at, real quick, number 2, where does it fail? Do you guys see number 2 fails? Yeah, what's the limit as n goes to infinity of this? What is it? 1/2, good, powers are the same. Limit is the ratio of the coefficients. Okay. So let's look at, 3 gets a little tricky. Yeah, let's look at 3. How many of these are there? There. So what's the first thing you want to check?
If the limit
Now I'll do the
is
limit
0.
first, right? That makes sense, because that's sort of normally the easiest one, but let me see if you guys can see how to do this. And again, remember, you're only looking at the part that's next to this. So this is my an, yes? So you don't have to carry the -1. The -1 has told you, hey, use the alternating series test. And like, okay, I will. And then the rest of it is what you're checking, yes? Don't carry the -1 thing around with you. It's going to freak you out. How do I do that limit?
Isn't it infinity over infinity?
Which
So
means
then
I can
it
use-
means, so then you need to
Oh.
use the
Fridge,
what'd you call it?
Hospital
the
man.
French, the
Old French
the
man.
French
Old French guy.
emergency something.
Old French medical guy.
Yes.
Right? The old French medical guy.
Yes.
Y'all know that one? OFMG? That's it's almost something else. Okay. So can you guys, is everybody with me? We're using L'Hopital's in case you're not picking up on my weird shit that I'm talking about. L'Hopital's. Why can I use L'Hopital's? Because it's indeterminate form. I'll do the derivative at the top. Okay. You really should put x's in there, but what's the derivative of the bottom? I should really write my name.
2n to the, 2n natural ln 2?
Yeah.
Yeah, okay. I got there.
Now that's
Eventually.
easy, yes? If I let n get big, what does this do?
Goes to 0.
Goes to 0. Check. You're almost sad. Because if it wasn't 0, you'd be done, right? If it wasn't 0, you'd be done. Okay. So that's requirement number 2. So now what do I have to check?
If
Yes?
the,
Real quick, can you guys see these are going to be positive terms? They have to be positive terms because the other part of this is this, yes? And they are positive, yes? I don't know if you guys are with me. I don't know what to do. Okay. What is an plus 1? And what's an?
n over 2n?
Just n over 2 to the n, yes? Is it obvious that this is smaller than that?
Yeah,
Yeah.
because the bottom degree is
The bottom
bigger.
gets bigger, yes?
Yes.
Does the top also get bigger?
Yeah, but not as fast.
You sure? Can you show me? Do you see what I'm saying? So, something you could rely on. Now, this would work if you wanted to show that this is truly less than or equal to. I don't know if you guys know this about. If you think that A over B is less than C over D, you just have to show AD is less than BC. I don't know if you guys know that. Show AD is less than BC. If that's true, then the original inequality is true. So if I want to know, is 11/37, is that less than 14 45ths? Yes? I could just do 45 times 11, which is 495, and 14 times 37, which is, I don't care, 378, 2, 148, 518? No? Sound like I said no.
Hold on, my
70,
calculator
8,
screwed up.
2.
518.
Oh, God. Is it 518?
Yeah.
Look at me go. Is that true? Therefore, that is true. This is less than that. You guys with me? Really good thing to know. So if you want to investigate this, you multiply that up, and you say, is that less than 2 to the n plus 1 times n? And then you hope you could see something. You can't always see something. So I could say, this is 2 to the n times n plus 2 to the n, yes? And I could say this is, do you guys see how this is 2n times 2 to the n?
Yeah.
Do you see how I can pull a factor of 2 out? Do you see how this is here? But do you see how it's still kind of messy? I don't know if that's really true. So that could work. So, you either can try to show directly that an plus 1, and you just write what an plus 1 is, and an, show that that's less than or equal to. Sometimes that gets messy. So what can you do instead? If I have a function and I want to show that it's not increasing, with the word increasing, brings up memories of what calculus? Yes. Right. So my associated function is this. Is that cool? What is the and if you wanted to, you can write this as x times 2 to the negative x. So you can either do quotient rule or product rule, yes? So what's the derivative of this? So I take the derivative of x and leave this guy alone. Is that cool? First one's nice. So I'll do that one since you didn't want to. Plus x times derivative of 2 to the negative x. What's the derivative of 2 to the negative x? 2 to the negative x times
natural log.
natural log of 2 times Negative
It's
1,
negative
yes, because the chain rule comes into play for the power, yes? The inside is more than just x. Can you factor that? Can you factor that? What do both of those have? 2 to the negative x. So when is that? So, I want this to not be increasing. What must be true about this then? When is the function increasing? When its derivative is? When its derivative is? Sorry, I think you said it. Alright, I was expecting positive, but greater than 0 is positive. So therefore I want this not to be that. So I want this to be less than or equal to 0. Yes? So we all know derivatives tell me if the function is increasing or decreasing and where it's doing that. Yes? We know that. Here's something that says, hey, you need this thing to be not increasing. We're like, oh shit, I can use calculus. Who knew? It has a purpose. Can 2 to the negative x ever be 0 or negative? So you can just leave. And then I can solve this. 1 less than or equal to x natural log of 2. So x has got to be greater than or equal to 1 over natural log of 2. What is 1 divided by natural log of 2? Who's got that? It's gonna be like 3 usually. No?
1.44269504.
Okay. So what that means, where did x come from? We replaced what with it? N. So therefore n has to be bigger than that. Yes? So the first term is not true, but is it true forever after that? So we're golden. Almost everything, now real quick, just come back. Why did we do all this, what we just did? Because we got the limit to be 0, check. What's the other thing we need? The an function must be non-increasing. Basically decreasing or maybe staying the same at the most. You guys with me? And if I can't show that directly with the an plus 1 and the an, if that gets kind of messy, just take a frickin' derivative and see when it's less than 0. You guys kind of with me? Now, almost everything we talk about doesn't have to be true for the first finite number of things, as long as it eventually starts doing it forever. So let me see if you guys understand what I just said. So do you understand that this is only true for n greater than or equal to 2 then, yes? Is it true for 1? Nope, because it's got to be greater than or equal to 1.44. So it doesn't work for 1. Jeff, but who cares? I could just pull the first element off, couldn't I? What is the first element? 1 half. And then what would the rest of this be? Let's see if you guys can do this. I pulled the first term off, yes? And there's still an infinite number of other things. Where's it going to start now? 2. Freaking 2. Of course it's going to start at 2, yes? So couldn't I pull another one off if I wanted to? Couldn't I pull the first 18 billion off? Wouldn't they still be finite? If I add 18 billion finite numbers, could it ever go to infinity? No. The only way I can go to infinity with finite things is to let that go to the infinite number of them. Yes? You guys kind of with me? So, this thing needs my function to not be increasing. My function could increase for the first 18 billion terms, as long as forever after that it decreases. That's true about almost every test we look at. It says your function must do this. Read that as, eventually your function must always do this. Because if it doesn't do it for the first 80 terms, I just can pull that shit out. Who cares? And then it's good for the rest of it. Maybe. So what did we just prove? Is this doing the things it's supposed to? Is its limit 0? Yes. Is it always non-increasing? Yes, because it starts above 1.44, yes? So this does what? Put your thumb down. What does this do? What does this series do? Converges. So if I add a half to it, would that make it go to infinity? Thank you. Okay. I have no idea if you guys are listening.
don't we have to fix the,
No. I know what you're thinking. So I changed this because I pulled the first one out. So this still stays the same.
oh,
Because what would I do next? What's the first one of this now? The second term, yes?
mhm.
Okay. Let's see. Oh boy. Yeah, so pretty much these work all the same way. Something like number 5, I would definitely do the derivative. Guys, go ahead and try to do number 5. Why do you think I started that one at 2? What if it was 1? What would the top be? Yeah, so there's no reason to include it because it would just make it 0. We'll see that kind of thing also. It's a tradition thing. Don't include the first term if it's 0. Yeah. Oh shit. So for Aljain series, how do you know you're supposed to use it? Well, you got a freaking -1 to an n power, yes? Then you know you have to use it. Check the limit. That's almost always the first thing you want to do anyway, because if the limit's not 0, you're done. And then check to see if it's not increasing. You have 2 ways to do it. A lot of time you're going to end up doing derivative. Because it's not easy to see the n plus 1 term versus the nth term. Who's bigger, who's smaller. It's not easy to see that. Yeah, real quick, on the quiz, I forgot I put this on there. You guys remember the part that said, "Dear God, do not use the interval test"?
Yes.
Okay, dear God. I've had people try. Hopefully everybody did the limit. Just the test for divergence. That's all you had to do. Yeah. Then you can say if it might or might not. I didn't say does it, I said might it, which is always less work. Well, let's make it official, Jeff. X. Now the reason I'm making that X is because who's gotten to the next step? What are you going to do with that? L'Hopital's. And L'Hopital's is derivative, and that only works on continuous functions. Natural log of n is not continuous. Why? Because what is n? 2, 3, 4. Is that continuous? No, it's not continuous, yes? So I have to kind of pretend like it's a continuous function. Keep going. People have trouble with this, so I'm just reciprocating, right? Negative power, so the 1/2 becomes a 2 up top, that moves up. I'm dividing by s.
Flips it.
Yeah. So this flips up, the X is on the bottom already, yes? Okay. Now, some people will do L'Hopital's again here, do you have to?
No, because the
Do you
top's
have to?
gonna
Do
be
you
bigger.
have to do L'Hopital's? So this will be 2 over? How many X's are left on the bottom?
Oh, 1/2,
No.
1/2.
1, yes. You got a whole one, you kill a half of it, so there's a half of it left alive. And what's this limit? 0, good, so the first part's done. Okay, now we start the second part. So we showed the limit is 0, so it has a chance. So now we have to do the second part. And what's the second part? So let me just show you how bad this would get.
Proving
And what do I have to show? An plus 1 is,
that is less than or equal to an.
yeah, what's an is just this thing, yes?
Mm-hmm.
So what's an plus 1?
Natural log of n plus 1 over the square root of n
Now,
plus 1.
really quick, didn't the bottom get a little bigger?
Mm-hmm.
Didn't the top get a little bigger?
Mm-hmm.
Which one got bigger? I have no freaking idea, right? Proportionally, I don't know. You guys see what I mean?
Mm-hmm.
You can't just say, well, yeah, no, you have no idea. You have no idea. And neither do I. I'm not gloating. We're all in the same boat. I have no idea. So what do? That
You have
failed
to
me.
Take the
Take the
limit.
derivative.
Or the, yeah.
We already did the limit. So we say screw you. And we say, what's the derivative of the associated 2? This is a beautiful problem for L'Hopital's. You do top and bottom separate. L'Hopital's looks as a function over another function. This is one function, I gotta take its derivative. So what rule could I use if I didn't want to bring this up? We'll do it this the other way. What rule could I use? Quotient rule. Does anyone remember my song for quotient rule? Yes. Does anyone know the song for quotient rule? Does anyone know Heidi Lo, Lily I, blah blah blah, bee ba doo, biddy ba ba boo? Alright. It rhymes either way you go, so I always hated it. So my song is top first, and actually my song is actually top first. So I take the derivative of the top first. Now listen, real quick side note, because not all of you have me for freaking 180. What's the product rule? It'd be f prime g plus f g prime, yes?
Mm-hmm.
The quotient rule looks a lot like the product rule on the top, except it's got a minus. Now, why would it have a minus? Isn't one of our functions on the bottom? Wouldn't one of our functions have a negative power? Therefore, when I take that function's derivative, a negative would come out. So of course it's minus when I am taking the derivative of the thing on the bottom. So that's why my song is top first. I take the derivative of the top first. And then minus, let the bottom have its term, yes? And then for some reason it's all over g squared. So coming back up here, that'll be 1 over x times x to the 1/2 minus natural log of x times 1/2 x to the negative 1/2 all over x to the 1/2 squared, which is x. That's nice. That's the one part of this that's nice. Go back to me. Okay. Stop it. Do y'all see how I get an x to the negative 1/2 here and an x to the negative 1/2 there? Alright, listen. It's gonna be a shit ton of algebra. This is a little piece of it. That's some good algebra. Right? And I understand, especially when I taught like business calculus. We'll do the calc and everybody was cool, and then I'd say, oh, the rest is algebra, and they all, oh, please do it. It's because they forgot their algebra, and I don't blame them, because you don't live in it, especially nowadays, you don't get to live in algebra long enough. What we call marinating in the math, you don't get to do that. So, if you have trouble with this kind of thing, if I go too fast, just let me know, yes? You're gonna have to be able to do this kind of stuff by yourself. Remind me, what is it we're trying to show that this is doing?
That it's not increasing.
Not increasing. So what does that mean mathematically?
That
No, not what it means conceptually. What does it mean mathematically? What I want to show is true about that expression.
A n plus 1 is
No. That is the derivative. What I want to show is true about the derivative to show it's non-increasing.
is that it's
Less than or equal to 0. Okay. So if I could factor this, I could do more with it. So let me write, what is this? What's x to the 1/2 divided by x?
1 over x to the
So I'll
1.
write like this, x to the negative 1/2, is that cool? Minus, I'm going to write this like this. Natural log of x over 2, x to the negative 1/2, is that cool? That's this piece? Over x. Can't I pull these down here? So I get a x to the negative 1/2 becomes positive 1/2 on the bottom. So I get 1 minus, in fact I'm going to do that with the 2 also. Let's see if you guys are cool with this. I want that to be what? What is this again?
Less than or equal to
Calculus
0.
wise, this is the what?
The-
This is the what? This is the derivative, yes? And what do we say we want that to do?
Be less than
Less
or
than or equal to 0,
0.
yes? Is this ever, no, real quick, is that ever 0? Because we're starting at 2, yes? Is this ever negative? So I can multiply by it and effectively get rid of it. And the 0 just eats it up, is that cool? So then I get 2 minus ln x has to be less than or equal to 0. If I add the ln x over, if I raise both sides e to both sides, I have x is greater than or equal to 1 e squared. What the shit does that mean? When will this series elements start to decrease?
After e.
When it hits n equal to e squared, or the next one. What is e squared? Can somebody do that? What is e squared? It's roughly, I don't know, 7 point, huh?
7.7
Yes?
point
Yes?
3
Yes?
8.
8, okay, thanks, so, good to hear. Here. Let's do something concrete with what we just did. Here's a series we're looking at right now, yes? And I'm gonna leave, well, alright, I'm gonna put this in there, but we're gonna ignore it, because I'm really looking at this piece right here, yes? I'm looking at this piece. The part you couldn't see for a moment. Alright, what's the first term? Natural log of 2 over the square root of 2, yes? Come back to me. What's the next term? Natural log of 3 over square root of 3, you with me? Can somebody, what is natural log of 2 divided by square root of 2? Do it again for 0.49?
Yeah.
Okay. What's natural log of 3 divided by square root of 3?
0.634.
Did that go up or down? Up. Where would it start to go down forever? At the 8th term, yes? So I don't like the way I really need you guys with me. The way they word these theorems, it makes it sound like it must always not be increased. No. I could just pull the freaking first n equals 2, n equals 3 up to 8. I could just, up to 7. You pull those out. And they're a little finite number, right? And then the series that's left that starts at 8. Is that matching what the alternating series test needs?
Yes.
Yes, because after 7 point whatever, it starts to decrease. And so is it decreasing forever? So what I'm saying is, I can pull out the first 7 terms of this. Or not 7 terms, but the first, up to 7, yes, up to an input of 7. So then it would be from 8 to infinity, is that cool? And they should be alternating. Damn it. Negative, positive, okay. You with me? Now, you all agree this is not infinity. This is not infinity, yes? And is this infinity? Why not? Because what 2 things did it do? The limit was?
The limit was 0.
Zero. And
it's not
it's not increasing. So you don't, let me see if I can get you to understand this. You don't have to pull those out, but I could, and I know I could. It just matters that eventually it is forever. So what would I have to see here? What would I have to see here that tells me the whole series is shit? I would have to see x less than 7 or something. Do you understand what that means? It's only decreasing up to the 6 for n equals 6. And then what is it doing forever after that? Increasing. That totally goes against what I need. You guys see that? Okay. The book always glosses that shit over, but that's huge. So I don't care what it's doing for the first 15 billion terms, as long as forever after that, in this case, it's not increasing. Because the first 15 billion versus infinity, have I said this yet? If you're at 1, you're as close to infinity as you are at 15 billion.
Yes.
If you get that, you understand why the first 15 billion terms, if they don't do what I want them to, who gives a shit?
Yeah.
Take them out. They're a finite number. What do you do? And the rest does what I want to do? I'm gold. Yes? All right. I know it's trippy. So alternating series test kicks so much ass. I just have to show the limit is 0 and that the sequence of elements is not increasing. And you have 2 ways you could do that. Okay. Last thing for today. We'll finish this up next time. One of my favorite tests, and again, I have no idea how that makes you feel when I say something like that. This is what's, all right, I was talking to somebody earlier. Unfortunately, they have left, and that makes me cry a little bit inside. I'll be okay. Let me ask you guys this. If you see this problem, can anyone see what, let me see if you guys, I'm going to use this terminology, and if you don't get what I mean right away, I'm going to explain it. Do you see what that's trying to be? Do you see what that wants to be? Let me ask it to you this way. Huh? Oh, sweet. It's trying to be 1 over n. When n gets really, really big, how important is plus 1? Not. When n gets really, 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 really big, how important is 4 times n? 4 times 18 billion is a lot, yes? But 18 billion cubed makes that nothing. It's like my wallet versus Bill Gates. He's like, thanks, Bill. You guys, so I understand your desire to just go, well, there you go, Jeff. It diverges because it would be 1 over n, yes? So you can't do that shit. So let me ask you this. Here's the idea. Here's the idea behind what's called the direct comparison test. We already know that this is trying to be 1 over n. What does 1 over n do? Goes to infinity, yes? If I plotted these partial sums, they would just kind of go to infinity, yes? Okay. If I could show that the series I'm looking at right now is actually bigger than 1 over n, then as 1 over n goes to infinity, it would push that series up, yes? You guys follow? Okay. I started with a more evil one than I wanted to. It's okay, Jeff. I believe. Yeah, let me do another one. This is a little, we have to come back to this. Let me show you what I mean. You give me one that's almost the same. Yeah, okay. So let's start at 3 just to be safe. Yeah, okay. It's basically almost the same, right? You'll see why I had to do that finagling. There's really only 2 things we're going to have to do here. And the one I had earlier was the weirder thing. So I want to start with this one. Remind me. So isn't that the same idea? Isn't that trying to be 1 over n? It's just got extra shit, yes? So I want to show that this is a floor for this. When I think the series I'm looking at diverges, I want to find a floor. Because if this is 1 over n, yes? This is 1 over n. If this sucker goes to infinity and this is bigger than it, does this have any other choice than to go to infinity? No, it has to go to infinity. Right? So the reverse of the ceiling coming at you is like floor taking you up. Oh shit. Okay. So how do you do that, Jeff? I don't know. Oh yeah. So here's the one. This feels like cheating. So let me make sure you guys understand. I want to show eventually that this is bigger than 1 over n, yes? You guys with me? Okay. So would you agree that this is bigger than n squared over n cubed minus n? Do you guys see why? Why is that true?
Because of the minus and the
Yeah, because this, here I'm dividing by more, yes? So then therefore this guy is smaller than it was. Are you with me? So here's the idea. Now listen, I'm not saying that I'm making this become this. I'm saying I'm trying to find a logical path that shows me that this is bigger than that. So that's why I'm allowed to do almost anything I want to as long as it's logically consistent. So if I take that away, are you allowed to do that in general? No. But if I do take that away, the result is less than it used to be. Yes? Why? I'm dividing by more than I used to be. So what can I do now? Same idea, yes? What can I take away now?
n.
Yeah. Now, why is that smaller? Because again, I'm dividing by more than I used to be, yes? If n is 3, I'm divided by 27, but here I'm divided by 24. So of course that's smaller. I'm divided by more. And what is n squared over n cubed? So 1 over n is smaller than this if you follow the chain back, yes? So when you think the series you're looking at, when you can see what it's related to, and you think it diverges, you have to find a floor. What do you think if it converges? You want to find a ceiling. You want to find something bigger than it. Because if this converges and this guy's like, I want to diverge, it's like, nope. You're always smaller than me, so you ain't got a chance to diverge. Yes? So I end up doing this all the time in my class, and later I'm like, okay, really hope that makes sense. One example of a ceiling. Let's see. What about, maybe I'll do, maybe I should, let me do this one. This would be the last thing we do. Ever. It's horrible. Little final destination stuff going on, sorry. Do you see how this is different? If I just take the 1 away, all right, let's go through this again. This is trying to be 1 over n. Therefore, I feel really strongly that this series is going to do what? Diverge. I feel really strong that this is going to diverge. Therefore, I want to show that this is less than 1 over n. Yes? If I just take the 1 away, why doesn't that work the same way as it did before?
Because you would be dividing by less.
If I divide by less, I'm making the result bigger. But don't I want my inequality symbol to go this way? Sorry. This way.
Yes.
Okay. I want to show that what I've got is bigger than 1 over n. That way 1 over n forces me to go to infinity. I want to find a floor. Okay. So what do I do then? So either, this is so beautiful, for direct comparison, either you just erase the shit away because it makes the inequality go the way you need, or you make what's there like terms with what else is there. What are the 2 most important pieces of my series that tells me it was 1 over n?
The n squared.
N squared?
N
N cubed. I don't want to get rid of those. Yes? So if I can't just erase, so real quick, why did the erasing work down here? Because it made the bottom bigger. So it made the result smaller, so it followed the inequality. Now I want to make the bottom,
You want to make the bottom bigger.
yeah, what did I just say here? Am I thinking the wrong way around? Oh God, hold on. Let me reset my brain. Yeah, I want this to be smaller than this. Right now, I'm having a conniption. Hold on. Yeah, if I take the 1 away, that makes the bottom smaller, which makes the whole thing bigger. There I am. Okay. It's been a long day. You guys with me? If I take the 1 away, I make the bottom smaller, makes the whole thing bigger. So what I do instead, if I can't just take it away, I replace it with like terms with this. Do you all agree I just made the bottom bigger? You all agree? Unless n is 1, yes? But does it work for every other value of n? Would you all agree that if n is bigger than 1, n cubed is bigger than 1?
Yes.
N cubed is bigger than n. You all agree? Did I just make the bottom? So it's either greater than or equal to, yes? There we go, now it's perfect. And what can I do on the bottom now that I wasn't able to do before?
Cancels the.
Well, I can add them, yes? I get n squared over 6n cubed, which is 1 over 6n squared. No, I'm sorry, 6n. Does that diverge? And our series is bigger than that, so does our series diverge? Our series is bigger than a series that we know diverges, so does our series diverge? Yes. So that's why it feels like cheating. You are allowed to change the pieces. You just need the string of inequalities to be true. I just need to show that, in this case, my dude is bigger than this other dude that goes to infinity. If I thought it converged, I want to assume my dude is smaller than this dude because it converges, and it would force me to converge also. Okay. So I kind of try to explain it in here with the ceiling and the floor. And I get a little more technical here. Yes? I get a little excited about the idea. But you can see the technical way to do this. Okay. And one big thing that this presupposes, you have to have positive term series. And again, the same thing applies. If the first 7 terms are negative, but every other term is positive, you can just pluck those out. Yeah.
So if you're to like the opposite way, if you were to do this opposite way to like prove that something converges, you would just like flip the inequalities.
Then you want to make, then you want to have the function you're considering, you want it to be smaller than some other function, yes? Because then the other function keeps it from going to infinity. So then you want to make, whatever change you make, you want your new thing to be bigger than it used to be. All right, that's plenty, guys. By the way, when's our next test?
After spring
Thursday
break.
after spring break.
Thursday after spring break. I'm not quite evil enough to put it on Tuesday. So what am I going to have for you for the next class? Practice test, and I'll have the answer to after spring break. Okay. All right, guys.
Oh, yeah.
Oh, thank you.
But there also comes